Good afternoon, everyone. So we will start with our lecture now. So hope my screen is visible to you all. So in our last lecture, we have started with our second unit working with private cloud. Okay, so in the second unit, working with private cloud, we have gone through whatever the syllabus that we had, that is private cloud definition, characteristics, then deployment models, CloudStack, OpenStack, then designing elastic, highly available and resilient infrastructure using OpenStack, CloudStack for varied application scenarios and financial technological implication of running an application. So here now, in our last lecture, we have started with this unit with the introductory part as per our the Swedish norms. Then we have seen the definition for private cloud, that is what is exactly the private cloud, which is the model of cloud computing where the infrastructure is dedicated to a single user organization. Let me log out. So a private cloud is a model of cloud computing where the infrastructure is dedicated to a single user organization. A private cloud can be hosted either at an organization's own data center, at a third party co-location facility, or via a private cloud provider who offers the private cloud hosting services and may or may not also offer traditional public shared multi-tenant cloud infrastructure. So in that we have gone through the private cloud definitions with why to use private clouds, what is the difference between private cloud and public cloud, why use VMware, what is a private cloud architecture, and is a private cloud more secure than the public cloud. So that part we have seen in our last lecture. So today we are going to see the characteristics of private cloud. So already we have seen the benefits of private cloud, what are the different benefits of public cloud, how private cloud is better than public cloud. That part also we have seen in first unit. So some of the characteristics are listed over here on the screen. So out of that, the first one is the scalable. So what is scalable? So it will be giving you the high levels of utilization, that is through virtualization and the size and maturity of data center. So scalable means as the private clouds are giving you the benefits of getting virtualization. So the size could be more and more to get reach of as many users as you can, isn't it? So as well as the maturity of data centers, that means you will be giving maximum benefits out of those located data centers. So we can say that it will be highly scalable. Then it comes to accessible. That means IT customers can self provisional and they will give you the access to each and every point, each and every data to different users. So how to give the access to different user, what will be the rights out of the means which type of rights you can give to your customers, your users. So according to that, the accessibility will be given. So the IT customers or the people who are working in IT will give the rights or the administrative rights over here. So this is also one of the characteristics, that to whom to give the rights, to whom should not or who should not be given the rights. That will be the task of the IT people only. So everything will be governed by these IT people only. Then third is elastic. Elastic is what? Appearance of infinite capacity on demand. So elastic means your cloud or the private cloud is giving you huge capacity of data storage, isn't it? So out of that, how much should be given to different user? So out of that infinite, what part will be given to which particular users? So that will be that will also be decided by these IT people who are working as the administrators over there. So that means the elasticity is also one of the characteristic, one of the advantage of private cloud. Then fourth one is shared. So what is shared? Shared means you can share the data between multiple users. Okay, just like our Google Sheet. At a time, you can share the sheet so that multiple people can edit that particular sheet, isn't it? So that means your workload will be multiplexed. Multiplexed mean it will be divided into multiple users, and at a time, say for example, within 5 minutes, you will be getting more and more output out of it. Google Sheets, then Google Forms are the best examples for that. Okay, so that the capacity will be pooled. And then metered consumption. One of the phenomenon is given over here, that is metered consumptions. That means ability to pay for use with no commitments. Means what? You can pay for whatever that you are using. So it will be the metered consumption. So like our prepaid card. Okay, so if I am doing the recharge of 1000 rupees, so and if I am having lifetime accessibility, then so for example, like our work from home packs, isn't it? So if I am using 30 GB pack, then if today I'm using 5 GB out of it. Maybe tomorrow I will be using 1 GB out of it. Just one time I have to pay, and I can use it at any time within the stipulated period. So it will be like metered consumption. So how much you will be using, for that only you will be paying, isn't it? So these are the characteristics of private cloud. Then coming to the next. So next is the CloudStack. So we will be going to study now the CloudStack. So I have found some of the videos for that over here. I will share some of them, which will be more and more helpful for us. Let me share my screen now. Whether my screen is visible to you, and whether the sound is audible out of that particular video, please reply. Hello. Whether the sound, whether the sound of audio is audible to you. Just give me 1 minute.
Hello and welcome to this module of this course on Apache CloudStack. In this module, we will introduce you to Apache CloudStack. We will go over its history in brief, speak about the core components and key concepts and terminology associated with Apache CloudStack. This module forms the foundation for the upcoming modules where we will start to implement our own cloud environment using Apache CloudStack. Before we talk about Apache CloudStack, let's quickly try to understand the basics of cloud computing. Traditional methods of hosting and deploying IT infrastructure meant we had to deploy monolithic data centers and physical servers. The lead time for this heavy infrastructure deployment was few days to few weeks. It needed large amount of capital spending upfront. This model often led to energy wastage, low utilization, and high efforts for the administration of hardware servers. It was rather difficult to scale these operations very quickly, whether it was to expand the operation to meet growing demand or to shrink operations due to reasons like seasonality. Cloud is a generic term used for a platform that provides hosted services over a network. At the core of cloud computing is hardware virtualization. Because of this, cloud infrastructure can provide us access to shared pool of computing resources which could be rented or leased on on-demand basis. Some of the main benefits and drivers behind cloud computing are: cloud computing allows companies to avoid upfront infrastructure costs and focus on projects that differentiate their services and products. In the recent years, this has enabled technology startups to invent and come up with innovative technologies and products without worrying about spending a lot on upfront fixed infrastructure. Cloud computing allows enterprises to get their applications up and running faster with improved manageability and less maintenance. Cloud computing enables us to rapidly adjust resources to meet fluctuating and unpredictable business demand. Major cloud providers are vastly trying to use renewable energy sources to run their data centers, and they are also coming up with more efficient data center designs to reduce energy consumptions per unit of computing resource. This obviously has tremendous advantages for the environment. Since cloud providers can manage their data centers more efficiently and cheaply, these savings can be passed on to the cloud consumers. The availability of high capacity networks, low cost computers, and storage devices, as well as the widespread adoption of hardware virtualization, service oriented architecture, and atomic utility computing have led to a growth in cloud computing. Companies can scale up as computing needs increase and then scale down again as demands decrease. Cloud computing has become a highly demanded service or utility due to the advantages of high computing power, cheap cost of service, high performance, scalability, accessibility, as well as availability. Some cloud vendors are experiencing growth rates of 50% year over year. To learn more about cloud computing and services provided by the cloud providers, please check out some of our other top rated courses. Cloud computing can be deployed in multiple configurations. The most popular configuration is, of course, the public cloud. These cloud services are provided by public cloud provider companies like Amazon, Microsoft, Google, Rackspace, and so on. Any individual or company can pay appropriate fee and buy the required services from these public cloud providers. The services are isolated for the individual customer so that they do not interfere with other customers' data or computing resources. But the consumers of the cloud do not have any control over the underlying infrastructure and hardware of the cloud. When companies need more control over their infrastructure, they deploy shareable IT infrastructure in their private data centers. This provides the facility and convenience of a cloud company to all the consumers within the company, at the same time giving more control to the company over their resources. This is called private clouds. But in many situations, companies need to adopt a hybrid approach where they make use of both public and private cloud infrastructure. These two separate segments are joined via secure network links, and the IT resources in both public and private clouds can talk to each other. This configuration is called hybrid cloud as a service, or IaaS, and Apache CloudStack.
Welcome to Storage Days, brought to you by Linbit and Shape Blue. Today we have Giles with us, who is the CEO and founder of Shape Blue. They are responsible for servicing and supporting CloudStack. Giles has over 15 years of experience in cloud integration and support, and is an active contributor to CloudStack. Giles, would you like to go ahead?
Yeah, thank you, Brian. Good morning, good afternoon, everybody, wherever you are. Thanks for the nice introduction, Brian. Although those number of years get bigger every year, so it sort of makes me realise we only have a finite amount of time, right? So what we're going to be talking about today is just an overview and an introduction to Apache CloudStack. So if you've turned up to this session expecting a huge technical deep dive, this isn't the right session for you. The developer Q&A later is probably a better session. But what I want to do here is just explain a little bit about Apache CloudStack, where it fits, how it's implemented, what sort of technologies it integrates, who uses it, just to give you a flavor of the technology, and also then, where to go next in terms of finding resources. As Brian said, I'm CEO of a company called Shape Blue. I'm going to talk just a little bit about Shape Blue in a second, but I also spend a percentage of my time acting as a committer and a PMC member of the Apache CloudStack project itself. In terms of agenda today, as I say, I'm just going to talk quickly about Shape Blue as an organization, talk about the CloudStack, its use cases, where it fits, actually what it is and what it does. I'm going to run a quick demo, a live demo of the CloudStack user interface, then dive into the architecture a little bit, how it fits together with other things, talk about the community, which is a really important aspect of an open source project like CloudStack, give you some pointers in terms of where you can go for further reading, and then we should allow plenty of time for Q&A at the end. So just a little bit about my company, Shape Blue. I could read that to you there. We are basically a cloud integrator. We build cloud environments for both service providers and enterprise customers. We focus almost solely these days on Apache CloudStack, and therefore by definition on IaaS. And that's just a course we've been led down in terms of finding a technology that worked for our customers, finding a technology that could be implemented in sensible timeframes, for sensible budgets. So we've effectively become a vendor who puts a wrapper around CloudStack, which is an open source technology. As a company, we've got offices in 5 different places. We're headquartered here in the UK. I'm speaking to you actually from home still in the UK. And just to show you some credentials that we are a real company who work with real clients. We work with all sorts of organizations. This first slide are predominantly service provider focused. Some of these guys here are things like universities, TV companies, some other organizations you may have heard of there. The only thing all of these people have got in common is that they all use Apache CloudStack. And also we've got some pretty big names and some pretty significant infrastructures in there as well. So that's just a little bit about us as an organization. The rest of this talk is going to be about Apache CloudStack. So what is CloudStack? First of all, I'm going to read this. It's a scalable, multi-tenant, open source, purpose-built cloud orchestration platform for delivering IaaS environments, IaaS clouds. But what I'm now going to do is just walk through each of those things in bold individually. First of all, scalable. CloudStack is almost infinitely scalable. The biggest production deployment we've been involved with CloudStack is over 35,000 physical hosts being orchestrated by CloudStack. It's designed to be multi-tenant from the ground up. So the original use case for the design of CloudStack was around the service provider public cloud use case. So intrinsically, it's multi-tenant with tenant isolation, tenant separation. It's open source. I'm talking today about Apache CloudStack. There is no such thing as Shape Blue CloudStack or any other CloudStack. It's an Apache project from the Apache Software Foundation. I am professionally, as is the rest of my organization, involved with that open source project. But what I'm talking about here today is a piece of tech that anybody on this webinar can go away and download afterwards, install, free for you to use and start experimenting with. The use cases, so as I said, initially, CloudStack was designed as a way for service providers to create public cloud environments for people to consume, IaaS environments. But increasingly, we're seeing organizations want to do an internal thing, i.e. a private cloud thing, but they want to leverage the tenants, the cornerstones of IaaS in terms of user self-service, in terms of isolation, in terms of metered use, etc. In a large enterprise organization, that fits with the model that, you know, IT is starting to become a commodity, or has become a commodity within those organizations. And, you know, just to give you an indicator, it's shaped blue. Our customer base is roughly 50-50. And I would say that extrapolates out to CloudStack users generally globally. Roughly 50% of the organizations are using it as service provider, roughly are non-service providers, so are using private cloud by definition. And obviously the combination of those two, hybrid cloud, is the logical conclusion for the third use case. Just drill down in a bit of detail in terms of what it actually does and why it was created in the first place. And what I've got here are some building blocks. I first saw a diagram like this, 12, 13 years ago, when this little company that sold books called Amazon popped up and said, hey, we're going to do a cloud computing thing. And we've launched this thing called the Elastic Compute Cloud, right? Which is the ability to buy effectively instances online. And the diagram they showed me then is still the same for IaaS. It pretty much looks like this. You know, you start with some networking, some compute, some storage in a data center. You would generally put a hypervisor over the top of it, although, you know, we've since looked into the concept of, of bare metal. A lot of people understand we have bare metal instances as well. Amazon then put a what they called a CMP, a cloud management platform, or an orchestration layer on top of that. And back then, Amazon wrote their own thing, okay? And they still maintain their own technology for doing that. That exposed an API, and that API, in terms of public cloud, was then consumed by an e-commerce platform. Amazon already had an e-commerce platform because they were selling lots of books and CDs and things like that at the time. So in terms of people being able to replicate that sort of functionality, this is the way CloudStack looks at it, is that we've got some networking, some storage, and some compute, okay? And I'm not going to go into too much detail about those today, but let's just assume that the organization has network, storage, compute. Obviously, there is a particular type of storage because of the nature of the webinar we're doing today that we would say is a great storage to fit with CloudStack, and it's got some great integration, that being the technology from Limbit. But from a CloudStack perspective, we're pretty agnostic in terms of what network storage and compute you've got. We then layer a hypervisor over the top. CloudStack supports, we say it's hypervisor agnostic because it supports pretty much any hypervisor you can think of. KVM, VMware, Zen, the new fork of Zen, which is getting a lot of traction, XCP-ng, Hyper-V, OVM. You can choose any of these hypervisors. You can mix and match these hypervisors in your environment. So CloudStack's putting an abstraction layer away from that. CloudStack is the actual orchestrator itself. It does the job of the cloud management layer. It presents a REST API. It also has its own user interface, which I'm going to show you later today. And that's pretty much all CloudStack does, okay? It's a very complex product to do that, because if you think of the infinite number of permutations of hypervisor, of network, of compute and storage, it has a lot of work to do. But in terms of the function it performs is to pull all those green blocks together, orchestrate them, and present them as an easily consumable API or an easily consumable UI. It also has some other sort of extensions. We've got a thing called the CloudStack Kubernetes service. I'll talk about that in a bit more detail in a second. We have a command line tool called Cloud Monkey. But then people start layering in other things. So if you're doing public cloud, people would normally still integrate CloudStack with an existing e-commerce platform, Kubernetes itself through the Kubernetes service. different developer tooling, automation tooling, multi-cloud management tools. But CloudStack is providing that glue in the middle and providing the abstraction between the infrastructure and the physical infrastructure and the hypervisor and the things that want to consume and automate that. In terms of the people who actually use CloudStack, I showed you a load of our customers earlier. They're all using CloudStack, but there's loads of other organizations. Some of these are our customers, some of them aren't our customers. Lots of different types of organizations around the world use Apache CloudStack. One of the things being an Apache project is that we're not great at tracking usage. It's one of the tenets of the Apache Software Foundation that we give software away. We don't make people register for that software. So what we also have is a whole bunch of people who we know are using CloudStack who don't talk publicly about it. But some of the world's largest organizations, a number of the world's top 10 largest organizations work with Apache CloudStack. Just look in a bit more detail, the advantages of CloudStack. And one of the reasons people get drawn to it over other similar technologies, let's get it out there. There's other technologies out there like OpenStack, for example, OpenNebula, open source. You've got VMware vCloud Direct. So they all do very similar things. One of the advantages that CloudStack has is that it is an integrated end-to-end IaaS product. Unlike, for example, OpenStack, which is a collection of loosely coupled, I don't know how many now, 34 projects. Each one is effectively providing a discrete service. Now, there are advantages of that model. CloudStack is an integrated product for delivering most of what most organizations want from an IaaS layer. It's proven at scale because of one and the first 2 points there. We can deploy CloudStack really quickly. It can be operational. To put this in perspective, a POC with CloudStack is a day's time frame, not a month's time frame. A production deployment of CloudStack is a week's time frame, not a year's time frame. It's a relatively easy, low-cost technology to operate and manage. It's truly multi-tenant from the ground up. We have the nice warm feeling we get. The development community is backed by and governed by the Apache Software Foundation, and it is predominantly a user-led community, which is really interesting. A lot of open source projects, particularly when they're at the top of the hype curve, take Kubernetes as an example, which is a fantastic collection of projects. But a lot of the contributions coming in there now are coming in from vendors who all see that technology as a route to market. I don't want to criticize Kubernetes, by the way. We're involved in that as well. But you start to get almost an imbalance. You get too many vendors involved in a project. CloudStack is effectively a user-driven community. So the people contributing to CloudStack are predominantly users of the software. So they're big service providers, large enterprises. And that gives CloudStack this sort of organic feel as a piece of software. And it removes the risk that a vendor or a group of vendors are going to try and push the technology in a different direction. It's got a relatively narrow scope. I showed you the diagram earlier. What CloudStack doesn't try and do is replace your block storage. We integrate with people like Limbit, for example, and other providers. Whole point of IaaS, and that can be done through a web UI. We have a command line, a REST API, and it also provides a high availability model on top of the hypervisor itself. Specifically, we have an integration point we call the CloudStack Kubernetes service, and this allows organizations to ease the challenges of deploying Kubernetes clusters. So if you are a public cloud provider, for example, and you need to offer a container as a service offering, or rather almost a Kubernetes as a service offering, you can do that out of the box with CloudStack. You don't have to do anything else. And CloudStack orchestrates and automates the creation of the clusters, the installation of Kubernetes, the configuration of the clusters, and then can do some quite neat things like handling sort of auto scaling out of the Kubernetes world, and a number of other things. And there is some movement at the moment towards people creating what are called CAPI providers for Kubernetes, and that's something that we're looking at from the CloudStack perspective. This effectively is the integration the other way around. So hopefully that just gives you a feel of what CloudStack's all about. I'm just going to jump in and do a very quick demo, hoping that the demo gods are with me. Just give me a second. This one on here. Okay, so this is just a vanilla CloudStack user interface. Most organizations will customize this, and it's a very customizable UI. I'm just going to log in as a plain user. Okay, so what I'm seeing here is just an overall view of what I've got in terms of compute virtual machines, in terms of data volumes, and in terms of networks. And I can explore the menu on the left-hand side, instances. I can look at my Kubernetes clusters. I can create groups of instances. I won't go through everything here. I can then look at what storage volumes I've got. I can also use CloudStack for taking snapshots. I can then use it to create quite complex networks. We've got a number of different networking models we can use. And then we've got the concept of templates and images, which allow me to create standardized templates to base new virtual machines on. So what I'm going to do, I'm just going to drill down and quickly show you the idea of an instance. So I've got a machine here is my database SQL 01. Get some background information on this. I can do all sorts of things, like, for example, I can go and look at its console. It says so I can actually get direct console access through to the virtual machine. I can start, I can stop it, I can take a snapshot of it, and then I can also sort of configure that machine. If I wanted to launch a new instance, very, very easy process. It's all in one place. I choose add instance. I choose what zone I want to deploy that into. I'm going to talk about these constructs in a second. What template I want to base that instance on. I've just got one here. This is just a raw test dev environment I have here, but I can have any number of templates, both community-based templates, mine or shared templates across the whole environment. And those could be templates which are obviously configured into use different hypervisors, different OSs, different bits of pre-installed software, etc. I can then drop through, choose how big I want that virtual machine to be, how many vCPUs, how much memory. Now, all of this stuff in terms of templates, in terms of offerings, is all configured by the admin of the environment. So as a service provider, you put a lot of thought into what size instances you're going to sell, how much you're going to charge for them, and that's where this list is created. So these could be labeled as anything: gold, silver, bronze, small, medium, large, micro, whatever you want. I'm just going to go with the small one for the moment. I can, as well as the root disk, I can choose to add a secondary data disk to this, and then I can go and choose what network I want to attach it to. I can even go and create a new network at this stage. I'm just going to take the quickest option because of time. Okay, and finally, I could choose SSH key pairs for getting onto the machine, etc. I'll just give it a name, demo 02. Specify I want it to start, and off we go. Oh, valid name, because I used a space in a machine name. Okay, so off it goes. Now, CloudStack is going off and queuing up the orchestration commands that are required to make that happen. So a lot of this, in this case, is speaking to the hypervisor. I think this is VMware underneath here. Could be KVM, could be anything. To go and create that. It will be speaking to storage. It will be speaking to network to go and create the components that are required to put this machine on the network that I've specified, or to create the new network that I'd specified if I'd done that at the time. Okay, it's not an instant thing. It depends on the size of your environment, but you can see this is starting. And actually, if I'm quick, I should be able to go into the console and actually see it booting. There we go, just waiting for its driver initialization. Okay, so that's the very, that's not even 101, that's just the one of CloudStack. That's the very, very basic use case, which is to be able to create and manage virtual instances. But remember, I'm doing that through an abstracted user interface, or I can do it through an abstracted API. We just back to this. So I show people the user interface because it's something nice to look at and you can visualize these things. But most of the interactions that operators have or users have with CloudStack is normally through its REST API, because this is where the power really comes in. Everything I've just shown you in the user interface and all of the other 99% of things that I didn't show you are all available through our REST API. So, a couple of examples there. I could list all my VMs, templates, create a new network, create a new virtual machine attached to that network. And the power of this really comes in is when you start to consume that UI in scripting environments, in config management environments like Ansible, Puppet, etc. Because what that lets me do, I'm going to go just through the user ones first of all. What that lets me do is build quite complex environments based on, example, a pair of database servers, a pair of app servers, a pair of load balance web servers at the front with some quite complex networking rules in between. Effectively, you've got my three tiers there. I can stand all of that up through a script. I could then run some tests against that environment, and then I could tear it down again. So that's one of our great use cases, is R&D and test environments. But if you are a large enterprise and you have to consume regularly, environments like an app development environment or something like that, okay, that sort of level of automation starts to just save person hours. Okay, so that's one of the other private cloud use cases. Automated deployment of production baseline environments. We've got a very large customer in Germany who are a very large SAP consultancy and reseller, and they're doing SAP installations, dozens per day, because they're such a large organization, and they have a standard deployment of those. They use CloudStack to be able to do that in seconds instead of what would have taken them days to do previously. So it's that level of automation and recreatability, some of the advantages we can get with CloudStack. Automated deployment of DR environments, triggering things if certain events happen, sitting underneath CI/CD pipelines, and then from an operator perspective, they can use the API for billing integration into CloudStack, creating custom user portals, all of that sort of stuff. As well as an API, we've also got a command line tool. We call it Cloud Monkey, and that's simply a wrapper to the REST API I just showed you there. So hopefully that's just giving you a flavor of what CloudStack does. I'm just going to talk about the architecture and effectively what it will and sort of won't work with quickly now. So first of all, from the virtualization perspective, that's what we support, which is a pretty exhaustive list. Yes, I know there are some other hypervisors out there in specific use cases, secure gov and stuff like that. But we cover, we think, 99.9% of the hypervisor deployments globally. Now, one of the interesting things about this, and actually one of the strange recent use cases we've seen with CloudStack, is if organizations are automating into those hypervisors, if they do it directly into that hypervisor, that's creating a dependency in their organization. So, for example, if you have an organization that is predominantly a VMware or 100% VMware organization, and they then start to automate their CI/CD pipeline on top of that directly into the VMware API, they're creating a very tight coupling to that vendor and to that to that virtualization platform. If you put something like CloudStack on top of that, you've created effectively an agnostic, a hypervisor independent API, because you want to create a virtual machine, you call our API and say, create a virtual machine, and the end user doesn't even need to know what hypervisor that's being stood up on. And this is a use case we see at the moment, people who are intending on moving between their virtualization estate from one vendor to another, put CloudStack over the top first, so they don't have to get those deep integration points into the hypervisor. We then have to choose our what we call our primary storage. CloudStack primary storage is effectively where the virtual machines live. CloudStack basically supports anything because it supports iSCSI or NFS or Fibre Channel or local disk. But it's worth mentioning that we also have some special cases, and that's one of the reasons we're here today. We have a number of technologies that we call managed storage, and they have much deeper integration than just using NFS with CloudStack. And that's some of the stuff. I know you probably heard about the CloudStack Limbit integration yesterday. I think the guys were talking about it. That work has enabled Limbit's technology to become managed storage underneath CloudStack, and that lets us do things like have much more granular control over that storage from the orchestration viewpoint. CloudStack also has a concept of secondary storage. This is where we put our low-grade artifacts, the stuff that we don't need high performance for. So things like images, templates, snapshots, things that we don't need that higher performance that we would do for a virtual machine. And this can be much cheaper, lower grade storage. Most people use NFS, although we do support Swift, ironically, and we can also back that storage out to S3 as well. CloudStack has a number of constructs to allow you to organize it as it scales, because, you know, as I mentioned before, the largest environment we've ever been involved with was 35,000 physical hosts. You can just think of the number of VMs that were involved there. You can just think of the number of different data centers that were involved there, and just the sheer size of the underlying infrastructure. So we've got these constructs in CloudStack. The top level we have is a region, and that's effectively an administrative concept. So that just lets us organize. And the classic example is literally a region: US, North America, Europe, Asia, what have you. A zone is defined as having basically, it normally maps to a data center. It doesn't have to map to a data center, but it makes logical sense because all.
I have not yet asked for attendance. Okay, keep in mind, when I will ask for the same, then only I will consider the attendance of the students. Otherwise not.
All of the infrastructure is contained at zone level, not at region level. Inside a zone, we can have any number of pods, and a pod is normally a rack in a data center, because a pod has a number of clusters, a number of virtualization clusters, and it also has primary and secondary storage attached to it. And we then can have multiple clusters in that pod, and each cluster is a different hypervisor. Okay, and again, all of this can be completely abstracted from the user, or it can be presented to the user. So, some of our large international service provider customers, they have literally these regions: North America, Europe, Asia Pac, etc. They have zones which are, Tokyo South, something else, literally data centers. They normally wouldn't expose a pod out to the end user, but then clusters, they might just have different virtualization technologies and that sort of thing. So key thing there is we've got a number of sort of scalable constructs in CloudStack. In terms of what it does as a technology, I'm not going to go through all of these boxes, but pretty much everything I've been talking about, you can see there. We've got a user interface. We're doing obviously workload management. We've got custom templates, that sort of thing. The key takeaway from this is that all of these things are done by CloudStack as a product. Okay, CloudStack as a product, it's its main brain is in a thing called the management server, and the management server pretty much does everything you see there, with a couple of exceptions. And that's what makes it easy to deploy, lower cost to manage, etc., etc. In terms of how we deploy it, up to a few thousand physical hosts, we literally drop in to the environment a CloudStack management server. You can see that there over on the left. I think I highlight it here. That has a MySQL database, or a couple of different MySQL databases that sit behind it. And what that management server is then doing is communicating through the hypervisor layer with the physical hosts, with the networking components, and with the storage. So it's just an orchestration layer. And one thing to get over to people in terms of sort of proving this, if you like, you could have a very large CloudStack environment and literally unplug the management server and the whole environment will still run. Obviously, you would have lost the ability to carry on orchestrating and to deploy new pieces of infrastructure and what have you, but the existing infrastructure is then just effectively virtualized infrastructure on your network storage and compute. And there's a couple of exceptions for its virtual networking model. CloudStack deploys a component it calls a virtual router. So for every network we create, it will spin up a virtual router that belongs to that guest account, and that does the routing. That's what allows that user to configure their firewall, to configure their load balancing. That's all done through this virtual appliance. And unfortunately, I haven't got this on the diagram, but our user interface is a separate component as well. So that sits now on top of the management server. Okay, one of the most important things, I think, I mentioned this earlier, is CloudStack is an open source, community driven project. And that brings huge benefits to the users of the software. It's developed by a community, and that community is run on predominantly mailing lists, but there's Slack channels and other forms of communication as well. And the governance model for that project is provided by the Apache Software Foundation. So that's why we have to refer to this as Apache CloudStack, not just CloudStack. I'm sure everybody's heard of Apache Software Foundation. Obviously, the people behind web server, Hadoop, Cassandra, you name it, yeah, hundreds and hundreds of very, very successful projects. And the key thing with Apache projects is they tend to be around for the long term, okay? They tend to be very organic, long-term pieces of software, more so than some other open source foundations. And the reason for that is that the governance model of Apache prohibits vendors or organizations from taking control of a project. And it's very, very strong. You can't, as a sponsor or a vendor, you can't buy a seat and influence the governance of the project. The governance of the project is controlled by a number of volunteers who are PMC members or committers. I happen to be both of those things. And it has a very strong set of laws and bylaws about voting techniques, methods, etc., etc. And what that means is we end up with software that, as I say, is very organic and has a very long-term footprint because people are confident that it's not going to get dragged in any crazy directions by a vendor or a group of vendors. The project at the moment is doing 2 releases a year. Occasionally there's an interim release, but that's the plan as it stands at the moment. We also have an LTS cycle which provides support for releases for 2 years. And it is it's a very diverse user-driven community. It's not a community that is overwhelmed with vendors. Obviously, people like the guys from Limbit have just done their integration with CloudStack, so they've been involved as community members in doing that. But this is not a project that is driven just by those vendors. It's overwhelmingly driven by the people who actually use the software.
So to that extent, there was a question with regards to that. What is Shape Blue's involvement in development of CloudStack? Do you have an idea of how much you contribute versus other people in the community?
Yeah, that's a really good question. There's 2 answers. There's the official answer I must give to that, and there's also the the answer that the attendee wants to hear, right? Quite an important concept is with Apache, organizations aren't represented, and that's a very organizations can sponsor the ASF, but you can't represent yourself in a project. So when I'm working, even though I'm CEO of a reasonable sized cloud integrator, when I'm working in Apache CloudStack, I'm doing so as Giles, not as Shape Blue. Okay, and that's a key tenet of Apache projects, and that's one of the things that stops organizations getting that control. There's no sense that we can buy influence. Literally, anybody who has been in the community for a while, any other committer could veto a vote on something that everybody else thinks is a good thing. And that model of consensus is what gives us that balance. That's the formal answer. The informal answer, I think informally, and it is actually, there is no absolute on this. I think Shape Blue is, amongst our team, is the biggest organizational contributor. I would say so. We probably contribute roughly 40-50% of the effort that goes into CloudStack, because we are the only organization out there who is just focusing on this technology. But one of the things as we've grown as an organization, obviously that percentage has gone up and got to where it is. One of the things as an organization we've tried really, really hard to do is not to start acting like a vendor. We completely get the open source model. Our customers don't buy software from us. They take the same as everybody else. But yeah, I'd say 40-50% is about where we're at. Brian, should we do that other question at the same time? It's probably a good time.
Sure. Yeah, the other question was, what is your opinion of OpenStack and how does CloudStack compare to it? That's obviously a personal opinion, but we'd love to hear your opinion.
That's a 2-hour talk all in itself. And you can see any of the recordings of me doing talks at conferences over the years, you'll hear that question always comes up. Very quick summary. Both started with similar ideas, okay, in terms of IaaS, but it was about what the vision was for those things. And OpenStack's vision, which was once it was over just the NASA stuff and it started to become with the big vendor players, their vision was we create this all-encompassing cloud operating system for the rest of the world, right? And we all know that there was some commercial stuff about VMware and what have you. And it had this huge ambition and has now turned into this massive foundation with 30-40 projects all in itself. CloudStack was just effectively a piece of software, happened to do the same thing as that vision and did it as a piece of software, right? Now, going back 10 years, 8 years probably, the analyst community and the media loved that 2-horse race of which one's going to win. And certainly, yeah, I get it. OpenStack got all the hype, but we were there waving, saying, hey, we've just won this customer. We've just done that. Because actually people who were really doing this back then were coming to CloudStack and they were deploying it in a few weeks or a few months, not in a few years, and have now been quietly trading and running some of the world's largest public clouds on it. So, where we've got to now is this huge foundation of all these different interconnected projects, which is called OpenStack, versus this one project of Apache called CloudStack, which you can install and do what you want for an IaaS perspective. I hope that answers the question. As I say, there's another hour and a half of background to that, but I'm sure we haven't got time for that today, Ryan. So just going back to the slides here, project today, just over 200 committers in the project. The PMC, which is like the management committee, is made up from people from a whole range of organizations. And just to give you some metrics, this was up until yesterday. In the last 4 weeks, nearly 600 mailing list messages from 70 different contributors, 108 merged PRs. You can go and look at GitHub, go and look at the project on GitHub and see these same numbers if you want, from 39 different authors, around 1,600 package downloads of Apache CloudStack. So as a project, we're a vibrant, busy project with a lot of development, a lot of new functionality coming out. represented, the development community is represented from people from all sorts of different organizations. Now, I will openly admit that this next slide is horribly out of date. And I maybe should have taken it out, but until the spring of last year, we used to do loads of meetups and events. We still do meetups and events. They don't look anything like that at the moment, although I'm hoping to see those come back next year. Generally, there's a couple of different things. There's lots of different user groups, hacker groups focus around CloudStack in all sorts of different, or user groups focus in all sorts of different parts of the world, right? So I'm involved in one called the CloudStack European user group. There is also a separate user group, which is the German user group. There's a San Francisco Bay Area user group who meet up. These tend to be sort of ad hoc. There's nothing formal about them. They're just a bunch of people who are interested in the technology. But much more formally, every year we have a conference for our technology. It has its own website, cloudstackcolab.org. Last time we physically got together was in Las Vegas seems a long time ago. Autumn, fall of 2019. We haven't been allowed to go anywhere since then, but we're actually doing our first virtual conference 8th to the 10th of November this year. So that's coming up in a little over a month. That's free to register if anybody's interested. I think there's 30 something technical talks. There's a lot of vendor talks going on. There's some great workshops. There's a hackathon. So if anybody's got some spare time, please register and come along and learn more about CloudStack. Where to go next in terms of further resources? You can download CloudStack and start playing with it. You can get the product from download.cloudstack.org or ShapeBlue, my company provider, effectively a mirror of that. The project website is there. There's a link to the documentation. We'll share all of these links and slides afterwards. If you want to get involved, want to start asking some questions, maybe you hit a few problems, the place to start is the CloudStack mailing lists, which are quite an old-fashioned thing that Apache insists on having, their email-based lists. But join the user's mailing list, say, hi, I've just installed CloudStack, this is happening, or I've got some questions, and you'll get people from all of the organizations I showed you logos of earlier offering to help you. They're generally a friendly bunch. It's a friendly community. As I mentioned, we've got the Collab conference, that's worth attending, or the CloudStack European user group. Both of those entities, if you like, are virtual at the moment. We're all hoping come next year that we can all finally get back on some planes and in our cars and actually go and meet each other for some of these things. That is pretty much it from me. We've had some questions. Any more to come?
So this was the introductory part for the CloudStack. We'll see anything if it is there for the deployment.
Hello and welcome to this quick CloudStack demo. My name is Michael with midnetworks.com. And in this video, we will go over CloudStack's main features and benefits to help you understand what makes it so powerful and in demand in the market today. When we think of reducing IT complexity, cost, and time, we think of the cloud. With CloudStack, you are given all the tools necessary to help you deploy your project without worrying about software, hardware, and IT resources. CloudStack orchestrates all the necessary resources for you so you can start deploying your cloud servers instantly with the required computing power, storage capacity, and networking services, all done from within one web portal and without being locked to vendor-specific requirements. To help understand this better, I'm going to log into my CloudStack client account. And let's start by looking at my cloud portal or my virtual data center. You see that I have a number of virtual machines currently running. I have a number of private networks sitting behind a virtual firewall, a number of consumed public IP addresses, and the latest events related to my cloud account. So let's take a look at the Instances tab. This is where the majority of time will be spent when working with virtual machines. I have a couple of Linux and Windows machines currently running. You can tell that from their status. To deploy VMs, it's quite simple. Just click on the Add Instance button on the top right corner and follow the instance wizard. So let's start by selecting a zone. Currently, we have it configured as Toronto. How you want to deploy the operating system for your VM via template or ISO. So you can use the template option and select one of the pre-configured Windows and Linux images, or you have the option to install your operating system from your own ISO image. In our case, I will select template option. From templates, I will select Ubuntu server. Next, I have to configure instance compute properties. Based on what you need, you will select the appropriate CPU size and memory. I'm going to go with medium instance. Now, this is an optional step to add additional disks to my VM. By default, each instance deployed from templates comes with a 50 gigabyte disk, so I'm going to skip this step. Here's another optional step. If you have affinity groups configured, you can control where the VMs will be running. Since I have none configured, I'm going to skip this step. Now, I will need to select a network. I'll select private if I want to put it behind a firewall, or use the public network if I have the VM on the public network without firewall. In our case, I'm going to deploy my VM on the private network, so I'll keep the default option. Finally, I will give my VM a name, review options, and click on Launch VM to deploy. Okay, now our VM is deployed. I'm going to save the generated root password so we can log into the machine later. Then, let's check this new instance. You see, under the Details tab, you have control options. Most of them are self-explanatory. Stop icon to stop the VM, reboot to reboot, take snapshot of your VM. With this, you can take a one-time snapshot so you can revert back to it if you need to. I'll discuss this later on. When we talk about storage volumes. Destroy instance, that's if you want to delete your VM. Attach an ISO media if you've uploaded it to your cloud account. Reset root or administrator password if you need to. Change service offering, that's if you want to upgrade or downgrade your VM compute size. Full console access to your machine with basic controls. Reset VM option, you can use this to revert the VM settings back to the original state when you first deployed. So you can use this if you want to start the VM fresh without the need to delete and redeploy it again. Underneath, you can view attached volumes. In this instance, currently, I have only the root volume. View snapshots if you've taken any, and finally, view affinity groups if you have it configured. Now, let's look at the NICs tab. You see I have one NIC on this machine. If I've added more NICs, they're going to be displayed here. And as you can see, here all the details for the default NIC 1 are displayed. Network name, IP address, gateway, and other details. On the Statistics tab, you can view basic information about the VM. Now, let's switch gears a little bit and talk about other options such as storage. Here, you can add storage volumes to any of your virtual machines at any point in time. Let's say you need additional disk volume added to your VM. It's pretty simple. Just click on Add Volume, and let's call it Disk Backup. Pick a zone and select size, then click OK. Now the disk has been created. All we have to do is attach it to our VM that we just created. So let's click on the disk, then click on Attach Disk. Select the VM you want to attach this disk to, then click OK. Now this disk will appear in the operating system. If I go back to my VM now and look under Volumes, you see my disk backup is available and ready to be used. If you no longer want this disk, I can click on Deattach, and this will deattach it from the VM. Then I can go and attach it to another VM. This is if you want to transfer data between VMs. You can also download the volume to your PC if you'd like to make a backup. You can also resize the disk when you need it. You can expand the disk or shrink it. Storage volumes can also serve as backups of your environment. You can take a snapshot of your VM, which will create a copy, which you can use to quickly recover your data when you need it. You can take a one-time snapshot of your VM or set up recurring snapshot where you can specify when and what time to take these snapshots and how long you want to keep them for. This way, you can keep a history of your environment and roll back to it at any given time. At this point in time, let's assume you have built and configured your VM and you're happy with it, but now you want to deploy more VMs, maybe with the same or smaller configuration. You can certainly spend time deploying a new VM, configuring its settings, or you can snapshot the root volume of the existing VM, then convert it to a template, then use that to build other machines. This way, you can quickly roll out your VMs with little time and little effort. I already created a template for one of my Windows machines, so if I go under Templates, you see that it's visible. Now if I go back and click on the Instances tab, click Add Instances, select Template, then click on My Templates, you see that it's visible. All I have to do is complete this wizard to create my machine. Now, we've covered instances, storage, and templates. Let's move into the Network tab and check out what we can do here. Networking can be pretty tricky and complex when you get to configure switches, routers, and firewalls, but with CloudStack, it's really quite simple. Now you can set up basic or complex networks easily. You can also configure firewall, port forwarding, and load balancing rules with just a few clicks. In my cloud account, you can see two networks. Public IP network, which is a shared network. This network is used when you want to deploy VMs on a public network. Private VM network, on the other hand, is a private isolated network. If you need to create additional isolated networks like it, click on Add Isolated Network, fill in the required details, and add it to your account. Since we already have one set up, let's take a look at what we can do inside this isolated network. You see from the Details tab, I can change the name of this network, restart it, and delete it. From the egress rules, I can configure traffic that's going outside. By default, all traffic is allowed. If I click on View IP Address, you will see the current configured source NAT IP. I can assign an additional public IP by clicking on Acquire New IP. If I click on Source NAT IP and look under the Details tab, you see that I can configure VPN access to this network. And with the Configuration tab, you see that I can control incoming traffic to my network via a dedicated firewall that comes with my cloud account. I can set up port forwarding for incoming traffic to my virtual machines. I can also configure load balancing for services between my VMs. Now, let's go back. This time, I'm going to show you how to create a virtual private cloud, VPC for short, which is a virtual network that is dedicated for your cloud account. This is used if you want to create a multi-tiered network. Let me show you what this means. I'm going to click on Add VPC. Let's give it a name. Description, zone, and superseder. which is an IP address that should be large enough to cover all different subnets that you want to create. So each subnet that you're going to create will take a smaller subnet from that superseder block. I will add 10.0.0.0/16. This should give us about 256 Class C networks to work with. Add DNS. Then click OK. Now the VPC is created. Let's create tiers with it. I will add one for LAN network. So I'll give it a name, gateway, and netmask. Now I will create another segment. This time I will call it DMZ and follow the same steps. Now, you see how easy it is to create different segments? All that I have to do when I create my instances is to assign them to the appropriate networks. VPC also allows us to assign additional public IP addresses, control traffic to those segments or tiers, and we can also set up a site-to-site VPN connection if you want to connect this VPC to your corporate or home network. So that was a quick look at how to build your environment in the cloud using CloudStack to provision virtual machines, managing virtual disks, and finally, how to configure basic and advanced virtual networks. I hope you found this informative. Thank you for watching, and stay tuned for more.
So here the example of launching CloudStack is been given in the video. I will share the links also in the notes so that you can go through it once again. One more video of just 4 minutes I will share with you.
Hi, I'll be going through the process of deploying a virtual machine from the CloudStack UI. Now, in order to do this, there are 4 things that you need to pass to the CloudStack API, which will be the zone, the network, the service offering, and the template. Okay, so the first thing we do is we go to the instances view, which you can find by clicking on compute and then on instances. So here's a list of all instances, and currently there are not any. So we will be adding a new one by clicking the Add Instance button. Okay, so the first thing that needs to be specified here is the zone that the instance will be created in. There are also fields here for selecting a pod, cluster, or host where the instance will be created in. Say if you want to put it on a specific host, you can put that in here, but I'll just leave it as is for now. And the next thing is to select a template or ISO. Now, when you do a fresh installation of CloudStack, it does come with a built-in template. There are no built-in ISOs. Those you have to upload yourself, which can be managed from the Images tab. Okay, moving on to the compute offering. You choose what the specification of the virtual machine is going to be here. These are the built-in ones, so I'll just be going with the first one. Okay, here you can decide if you want to have an additional data disk for storing data on your virtual machine. But I'll just leave this one as is as well. And again, the disk offerings can also be customized. If you go here to service offerings and go to disk offerings, you can manage it from there. Okay, so the last thing here would be selecting a network for the virtual machine to connect to, so that you can access the virtual machine through the network. I've already created one, so I'll just leave it as it is, as it has been pre-selected. Okay, the next thing here is the SSH keys, which I'll just leave as is because I don't have any keys set up. Okay, advanced mode, this is where you specify the boot type or the boot mode in case you need UEFI for your virtual machine. But I'm just going to leave it on the default settings because I don't need that right now. Okay, and these other things are all optional. You don't have to fill those out. So here we go. Once the state changes from starting to running, you can click on the virtual machine name and then open up the console by clicking this button here, and then you'll see your virtual machine running. All right, thanks for watching.
So today we have seen the basic parts of this, how it is been implemented practically, that part we have seen. So the theoretical concepts related to this, like the architecture, means from the point of view of exam or as per the syllabus, that part we will see in our next lecture. And related to this deployment, if any particular video if I will create, that also I will share with you. And depending on this only, I will share one assignment with you. Okay, so now you can give your attendance and we will stop here. Thank you very much.